my screen because I didn't.
Oh, okay.
So today's lesson is about electrostatic. So when we talk about electrostatic is the branch in physics, whereby this branch in physics, it deals with the study of stationary electric charges. It deals with the study of stationary electric charges, and then or electric or static electricity. So in this one here, we have things we call it electric charge, as I've indicated. We're going to start with an electric charge. You can take note, or I'm going to send you the note. Electric charges. So you must remember when we talk about electric charges, in this, if you have a matter, or it can be an object, né? So an object or something, or it can be anything, it will have particles. It will have a particles. So in these particles here, it will have a proton. It will have a proton, and also this object, it will have an electron. So when it have electrons, you know that proton is a positively charged. It's a positive charge, and also electron is a negative charge. So when you have that, when this object have those two, there is a possibility that in this object it can have the protons, and the protons, I will indicate them as positive, and the electrons, as I will indicate them as negative. They can have the same charges. They can have equal charges. Equal charges. So when they have equal charges, that's when we're gonna say they are neutral. This object is neutral. Is neutral. So the object, if they have equal charges, we're gonna call it a neutral object. It's a neutral. It's in neutral. And if this object have, let's say this object, it have more protons. It have more protons than electron, more protons than compared to electrons, then we call this object is positively charged. We call it a positively charged. Positively charged. So, which means if it have more electrons than protons, we gonna call it, it's negatively charged. So when you are dealing with this one, we have a guy called Coulombs. So Coulombs, he contributed a lot in terms of electrostatic. So Coulombs, there is a Coulombs law. We have a Coulombs law, whereby this Coulombs law, I'm gonna state it, and we use his formula to calculate Coulombs law. Let me just write it down. So Coulomb's law, they can ask you in the question, a question can ask you to state Coulomb's law. So Coulomb's law state as follows. It says that the force between two charges, 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 the force between two charged, not charges, between two charged objects. is directly proportional to the product of their charges. Is directly proportional is directly proportional to the product to the product of their charges of their charges and is inversely proportional to the square of the distance between them, and inversely proportional this one is distance, and a distance between them. So what is the meaning of this statement that I have read here? So the force between two charged objects, which means we have an object which we can call it Q. Let's name our project Q. This object, there are two objects. So we can call this object Q1 and the other one we can call it Q2. Objects is directly, when they use directly proportional, it means that it's directly proportional to the product of their charges. So now directly proportional is represented by this, né? This thing here. So when we say directly proportional or inversely proportional, so which means we are saying that when this increases, also this one increases. So if two things are directly proportional, if I have A here, if I have an object A, and this object A is directly proportional to object B, so the relationship between these two is, if it's directly proportional, it means that when A increases, also B is going to increase, or B will decrease. Either one of the two is either B can increase or A will decrease. So the relationship between the direct proportional relationship, it becomes a linear line, straight line. It becomes a straight line relationship. So a straight line can also be represented in this format. This is a straight line. So it can be a decreasing if we have Q here and B. The more B, if you see, when B is decreasing, what is happening to the relationship to Q? To Q also is what? Q is increasing. You see that?
Yes.
When B increases, Q is increasing. So the relationship, which is a straight line, we call it a direct proportional. So when we say direct proportional, and then for inverse, here it says also to the product of their what? Product of their charges. The word product, it means that those two things, they are going to be multiplied. It means multiplication. Multiplication. So when we talk about multiplication, it means that a force that is we are talking, Coulomb's law is talking about, is directly proportional to the product of Q1 and Q2. Ne? Then after that, the definition says of their product is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So inversely, it means that if this force here is inversely proportional to the distance. If the distance, we call it R. So it means that force is inversely, you put 1 over R directly, is inversely proportional to the square. Square means to the square of the distance between them. So this one, when you write it in terms of mathematics or physics, it means force is directly inversely proportional to the square. So into meaning this, you put 1 over R squared. So these two formulas, when we combine them, we are going to have a formula which is gonna look like this way. This formula is gonna say this, we can summarize, not in combining them. Let's say when we summarize it, we can say force is directly proportional to Q1, the product of Q1 and Q2, and inversely proportional to this distance, the square distance between them. So when we write it, we're gonna write it in this. So when you interpret this, it means that force is directly proportional to the two products and the two charged products, and then inversely proportional to the square distance in square. So if you are asked to state the Coulomb's law, if the question says state, you must write it in words, like the way I've written it here. Sometimes they can say state Coulomb's law. Maybe they can even be more specific, that you have to just use the symbol like this way. So if you write it this is exactly the same as everything that I've written there. Do you understand it now?
Yes.
So in this Coulomb's law, we have Coulomb's end up making his formula. So his formula was F, like it was F. The formula is the interpretation of his definition is force equals to K, and then in this K you have Q1, Q2 divide by, we can say K here, R squared. This is the formula to find the force between the two charges. So the K in this formula there is a constant. K is we call it this K here, we call it the K, we call it a Coulomb's law. A Coulomb's constant is called Coulomb's. And then where there is Q1 and Q2, Q1 and Q2, they are charges, is the charges. We call them Q1, and Q2 is for charges. We can just say charges. So these charges, they can be represented by Q. You will find that is written Q1 positive. It means that this is a positively charged charge. And then if it's written Q negative, it means that is a negatively charged. So now when we have this, we have a formula, and then the R, you know that R is just, I will just indicate it as a distance. Distance between the two charges. So now I will give you a scenario whereby we are going to apply a Coulomb's law, Coulomb's law formula. So when this scenario says, suppose we have two charges. Suppose, I'm just gonna write this question down. Let me just write it first, then I'm gonna read it to you. This is -6 then. So the question, it states that what is the force between them? So it reads as follow. Suppose we have 2 points charges, one with a charge of +4. We know that is an electron, microcoulombs, and the other with a charge of -6. We know that is an electron, microcoulombs. The distance between them is between them is 0.5 meters. What is the force between them? So after that, when we have this scenario, we know that, okay, we can decide that our Q1, which is positive charge, is equals to 4, and our Q2, which is negative charge, equals to -6, and then our R, which is a distance between them, is equals to 0.5. So we are given this we are given what we are given this data, and we also know that our K, which is Coulomb's constant, a Coulomb's constant, a Coulomb's constant is given as it's a constant which is given is equals to 9 multiplied by 10 to the power 9 Newton, and this is a unit or you can just say Newton m squared over c squared, column squared here. So this is the constant. So our formula to this, we know that our formula is F for force equals to K Q1 Q2 divided by R squared. So now what we do here, we are just going to substitute everything. When we substitute this, we can just write 9. You can also write with their, when you are writing, you must write also with their what? With their units. Units, I mean this here. You must also indicate with their units, or you don't indicate with their units, but at the end, remember that force equals to what? Equals to Newton is N. Then which means you're going to say 9 multiplied by 10 to the power 9. In brackets again, the newtons, the force between these two now, if you, we're gonna check here. The force here, it was the first charge is 4. But when they say 4, this here we have macro columns. Macro columns means 10 is equals to, it means that is 4 times. You say 4 times 10 to the power 6. Micro columns means 10 to the power 6. So we say 4 times 10 to the power 6. In brackets, the other one we have 6 electrons, which is going to be 6, multiplied by again, what? 10. And it's not 10 to the, it's 10 to the power negative, negative 6. You write negative 6, multiplied by 10 to the power negative 6. So remember, macro columns equals to 10 to the power what? 10 to the power negative 6. Then you divide by your R. Our R is 0.5. And our formula says squared, you square it. So now when you have done this, you can use your what? You can use your calculator. When you use your calculator, you can you use your calculator and you tell me the answer?
Yes.
All right.
My calculator says negative 8.64 times 10 to the power of 11.
Times 10 to the power 11.
Yes.
Negative, okay, times 10 to the power 11. Did you, okay, when you use your calculator, let me try to do something. Just wait. That's why we must also come to solve, because can you take a picture? You are using Casio.
Yes.
Take a picture of on the screen how you wrote it. I want to see how you wrote it in your Casio.
Okay. I typed out the multiplication part first. Then I got the answer and I divided it by 0.5 to the power of 2.
Okay. I want to see how you wrote. You were in your calculator there, using your phone. Just take a picture on the screen so that I can see how you did it. I just want to see how you wrote it there.
Okay.
Yes. Okay, did you send it?
I'm about to send it now.
Okay. Yes, there is a reason why I'm saying you must send. I want to see how you use your calculator so that I can see, I can be able to help you.
Yeah, I just sent it.
Okay. Just give me a more. Okay, did you send it?
Yes.
All right. I'm in my WhatsApp here. Maybe it's gonna reflect now. Is it showing that is sent to me? It's not coming. Just resend it again to me. Let me. Okay, yeah, I got it now. So you see the way you are using the calculator is wrong, ne? You don't use it that way. Do you hear what I'm saying?
Oh,
You don't calculate, you
yes.
don't use it that way. Yes. So the first thing, okay, if you use that way, the method that you are using, you must first press equal sign. Then it will give you the
Okay.
answer first. Let's say, for example, if you are using that method, ne, first use in terms of brackets, only the one on top here. Ne? You see this one here.
Yes.
Without dividing, ne? Without dividing, then you say equal sign is going to give you the answer. Then you press divide, then you say 0.5 square.
Okay.
Mhm.
Let me try it.
Yes. Then when you are done on the top one, you must tell me that you are done. Then you press equals to.
Okay. Yes, I got the answer.
What is the answer?
Negative 2.16 times 10 to the
Okay.
power of 11.
Now say divide by, you say 0.5 to the power 2.
It says negative 8. It says negative 8.64 times 10 to the power of 11.
11. No, the way you are doing it is fine. Let me do a video call with you. You will do it when I'm watching, because the way you put your answers there in the video, the one when you send it, it was not right. So I will show you how to do it with let me call you with a video call on the phone, so that next time you don't have, you are,
Oh,
you are using your phone to be in class.
yes.
Okay. So you can answer the WhatsApp one.
I can answer.
Yeah, can you try to answer the call? I'm calling you. As it says, you are on another call.
Okay, I'll leave the meeting.
Okay, it's fine. You know what? It's fine. Don't go. You can just do this way. When you're using a phone, there is somewhere for camera there. You see that?
Yes.
Yeah, just enable your camera. Go and show me show me your calculator. I will be interested. Yeah, that's fact. Cancel everything there. Not delete CAC. Yeah, cancel. Then let's start typing now. Before you type, there is something called shift there. You see shift?
Yes.
Say shift. Okay, not shift. Don't press it. Just leave it. Because, okay, there is somewhere written A, B over C. It's close to yes, yes. Press there. Okay, it's fine. We have to first deal with that problem. Go to cancel the on there. Then press mode there in your calculator. Press 1. Then press that ABC. Let's see what will happen. Still doing the same. Okay, press cancel it, press mode. I want you to write in that form that it won't give you a problem. Press mode, standard 2, number 2. Then press that one again. Okay, it's not. Okay, cancel again. Just press number 3, the same process. I want it to show you in terms of the blocks. Number 3, okay. But not want to work. Just okay, it's fine. Then because your calculator is working, like press brackets first. Then press that one. Okay, press those numbers. Should I read them to you?
No, it's fine.
Okay. I will want to say, okay, it's fine. You can proceed. Can I see the screen? Okay, yeah, it's fine. Remember, is 10 to the power negative 6.
For which one?
Is 4 times 10 to the power negative 6. You say 4 times 10 to the power 6. It must be 10 times 4 to the power negative 6.
Okay.
That's where I think that's where it was wrong. You can change it. Yeah, 10 to the power negative 6. And the negative 6, that one which you used there is not the right one. You must use the one in the brackets. You see after ABC.
Yes.
Cancel that negative you used. That one you use is going to give you problems. When you say 10 to the power, it works when you are using, if you are saying 10 to the power, you must use the small one. Yeah? Press that one, that negative there.
Which one?
The one after you see ABC, where I
Yeah.
was saying press before. Down there is a brackets, negative, close brackets. Yes.
Oh.
Yeah. You see it's even small. Go and change the other side there with the arrows. Okay, sorry. Is there any way you are supposed to change?
No.
Okay, let me see your calculator. I have to have x, okay. 10 to the power c, okay, 9. Go down, at the first, with the, yeah, I want to see everything that you wrote there. Okay, go again.
That's it.
You see why your 10 is writing in a small, cancel that 10. Why is it like very small compared to 9? Delete it, write 10, 1, 0. Yeah, you see the problem. So we are going to start everything again, eh? Cancel everything. Now start again. I won't be saying anything now. Let me see the screen. Okay, yeah, let's go. Oh, you don't have to, okay, it's fine. Yeah, you can go. Yeah, proceed. You are doing it right. Yeah, you are doing right. You can proceed.
Should I get the answer?
Yes. Then now you can say divide 0.5 is squared to the power 2. Let me see before you say equal. Let me see before you say equal sign. You say 0, okay, the answer divided by 0.7. It gave you that answer, ne? That answer is given you because of we are in the standard format, ne? So if you take your answer to, if you change your, like your, what is it? If you change your,
Calculate.
yeah, to be scientific, it's gonna give you the answer of negative 4.32 times 10 to the power negative 4. So just, you can also go to mode if you want to, yeah. And then is this standard number compute? Okay, standard. Let's go to R number 3. No, it's not there. Just go back. Is there a back in your, okay? No, it's fine. Cancel there. Okay, just say cancel everything there. We saw the answer. Ne? Then type this answer, negative 4.32 multiply by 10 to the power negative 4. 10 to the power negative 4. Negative, you remember you used which one? Negative 4. And equal sign. It's not the same. It's not giving you exactly. Okay, it's fine. Just cancel it again. So exactly how you did that question, is the way
Yes.
you have answered it with your calculator is exactly the same way that you're supposed to do. Then you can go to shift mode. Then let me see. It says I see mode 2. Okay, 1. Press 1. Did you press 1? Say
Yes.
start. Press 0. 0 equals 2. Okay, so I just cancel again. Okay, so it's fine. So your calculator is okay. There is no problem there with your calculator. Now it's fine.
Okay.
Yes. So that's how you do it with your when you are answering. So if sometimes you just write everything same time, it's going to give you the answer you are going to get is going to be wrong.
Oh.
Yes. So that's what I wanted to. It's just that I will check how you can change your calculator to. You see that one there. this one whereby is A or B over C. There is something that you can do so that it can write in terms of a boxes. It's just that if I'm not sure the back of your calculator, and if you open it now, you will find that you have a something. There is not something. There is no paper. No, they didn't give it to you. There is a paper there.
Is it this one?
I know it's not, it's too small, that one. Maybe there was supposed to be a big paper for instruction of your calculator. Normally they put it at the back of your lead, but it's fine. I'm gonna tell you how you can change it there so that you can be in terms of a box and it will be more clear for you to use your calculator. So let's proceed with the lesson.
Okay.
So you got the answer there. So that's the answer for this one. So now when you have done that, like this is how we use the formula F equals to KQ1 Q2 over R squared. So the only thing that we're gonna work more on is to use your calculator so that you can get the right answer, because you can use this formula. The marker will give you these marks, but you'll find that they are giving you wrong in the last one. So we have to work with that. So just that here I don't have a scientific calculator, but I will try to download a calculator so that I can also scientific one like yours, so that you can see when I'm calculating it. So we did an example based on the Coulomb's law, the formula. So we also talked about okay, just give me 1 minute. So I just want to, you don't have to drop. I'm just checking something quickly.
Okay.
Okay, I'm almost done. Just give me a moment. I just want to check. All right. So now we're going to go to electric field, ne? Electric field.
Yes.
So at least you understand the formula that we have been using. So the one for Coulomb's law, I think you are fine. You just have to remember the formula. And I think the formula will be in your question paper. So I'm gonna erase here. So we're gonna do electric field. So in electric field here, in terms of electric field is a region of a space around a charged object where a test charge experiences an electric force. So the definition that I'm gonna give you is it's a region. It's a region of a space of space around a charged object, around a charged object. So this region around a charged object, if it's an object like this here, when they say electric field, it's like in the magnet. There is a region whereby it attracts like metals. So it's kind of like it's the same, more the same of that region, what they are saying. So it expresses an electric force. So the direction of the electric field is the direction in which a positive test charges would move if placed in the field. So I think I have shown you based on I've shown you this before. Remember there is a lesson that we did whereby I put a dot. Like it's like if it's positive like this way, they will go this way. You remember?
Yes, I remember.
So let's say if it's negative, then these charges, they will come and meet somewhere like this. That's what they mean about, that is the meaning of the direction. So, but we're still gonna do that. This one, I'm just giving you an example.
Okay.
So this is the directions. We also have something called the strength. We can also calculate the strength of the electric field. So the strength of the electric field is in terms of newtons per coulomb is N over C. This is just a unit, N over C. So you can be the equation, the formula for electric, when you are calculating the electric field, the formula is E equals to K. K, remember, is still Coulomb's constant, multiply by Q over R squared. So this is the formula for electric field. So you have a formula for electric field. You also have a formula for force. Remember the formula for force? They are different. F equals to K Q1 Q2 over R squared. This one is for calculating the what? The force. between the two charges. So you have now I will do an example with you. So if we have this equation, the question can say, suppose you have you have a point charge. Suppose we have a point charge. A point charge of +3 macro coulombs. Remember, macro coulombs means 10 to the power -6, ne?
Yes.
And then it says, suppose, okay, so what is the electric field? The question says, what is the electric field at a distance of 0.1 meters from the charge. So now when we are given what? We are given that this is it have a micro, okay, it is positive charge, is a positive charge, is positive charge, which is 3. And then we also have a distance of 0.1. So when we use to find the electric charge, you're just gonna use your K Q over R squared. Then when I substitute this, is going to be 9 times 10 to the power 9. And then again, it's going to be, the charge is 3. It's going to be 3 multiplied by 10 to the power -6 over 0.01 to the power squared. So if you use your calculator, try to use your calculator. When you use your calculator, the answer you're going to get 2.67 times 10 to the power times 10, whereby 2.7 times 10, I'm expecting you to get this answer. 2.7 multiplied by 10 is going to be 27. So you will have to get 27. And then electric field, remember, is Newton per watt. So when you do it, tell me if you are getting the same answer as me.
Okay, I'll tell you.
All right, no problem.
No, I'm not getting the same answer.
What much did you get?
I'm getting 270.
170. All
Yes.
right, let me just verify it now. You got 200 and okay, you got 270, ne? So I'm gonna verify with you now. Just give me a moment. Probably I'm thinking your answer is going to be right, ne? How can I change? Yeah, scientific. Yeah, no, I'm gonna be there. Okay, it's fine. It's 9 multiplied by 10 to the power 9. Again, and then 3 multiplied by 10 to the power negative. What is my negative here? Negative 6 divided by in brackets. You, how much did you get? Hello?
Hello, I got
How much? You said you got how much?
I did it again. It gave me 2,007,700,000.
2,700,000. That's the right answer. Yes, you did it right. So that's the right is 2 million, which means 2 million. If we are converting, it can be 10. We can write it as 2.7, né? Times 10 to the power what?
Of 6.
To the power 6. Okay. Yeah, that's the right answer.
Okay.
Yes. So this is how you worked with electric with the electric field and also with the forces. So we're gonna maybe have another, we're gonna proceed with this chapter maybe tomorrow, or else if I will have time later today, we can still have another class. You said, when are you writing?
I'm writing on Thursday.
Thursday. Okay, we still have time, don't worry. So I'm going to send you a question paper, ne? Let me, as I told you that we're gonna deal, I want us to do this question paper. Let me check. I think it's this one. You see, it's for grade 10 Eastern Cape. And this question paper, physical science, is for you guys.
Okay.
Yeah. So the questions normally in your exam, like you might find that your teacher is using more of these question paper questions. So I'm not sure if it's this. Let me check if it's paper 2. No, it's paper 1. I want paper 1, not paper 2. Quadrilateral metals sphere A and B are placed on the insulated big recharges of K. Yeah, I think this chapter is also based on what you are doing. You know?
Yes.
Yeah, yeah, I think it's also the one more of the same questions. Yeah, I'm just checking this side here. You see, okay, I don't see those formulas that I was giving to you. They didn't write them here in your formula sheet, but it's not a problem as long as you know how they are, you use them. So let me check another one. There is another one that I want here, 2016. Yes, even this one. Oh, this one is for NCS, but it's still the same, all the same questions. They're more of the same. You use the same thing, you have the same formulas. So this one here is for the magnet. Ne? The magnetic, I think we did it, whereby the magnetic force of non-contact. Define the term non-contact force. Define another example of, it's fine. So we have these two here. This is the question that I want you to do. I'm going to send you two small identical spheres A and B are suspended on a long zinc strand as shown in the sketch below. The sphere carry charges of, they give you to you there and there. Then which sphere has an excess of electrons? Excess of electrons, electrons, you remember, is represented by negative. It's going to be B. Ne? And then the two spheres are allowed to touch. What will the electrons be transferred from A to B or from B to A? They will be transferred from A to B. Ne? I'm giving you the answer already. The sphere are now separated. Ne? Calculate the new charge on sphere B when they are separated. When you calculate the new charge, you combine them, two of them. You say this plus that one, you're going to say this amount plus this one, then this will be a new charge. The answer is going to give you the new charge. Calculate the number of electrons transferred during contact. The number of electrons transferred during contact. So when they combine here, the combination here, the one which were transferred electrons, it's going to be negative 2 times 10 to the power 6, because they are going to be transferred to the other one. So when you check here, we have they already gave you some, there is some things that they gave you there, even the formula. So when you come here, you can check one of these formulas. I don't see it here. There must be electric circuit, electrostatic. For electrostatic, you are given N equals to Q over E. Ne? You can also use this formula to calculate the number of charges that were transferred. That's the formula that I'm gonna still show you. So your questions, they are not really asking more of questions. They don't ask you guys based on the calculation. Or did, when your teacher teaching you, did she also mention those formulas that I gave it to you?
No, he only mentioned the law of quantity. No, he mentioned the law of quantitative. No, I'm not sure about it.
Oh, okay. No, it's fine. I'm gonna check your books and see. Mara, those one which I was teaching you, is exactly what they teach you. They have to teach you in grade 10.
Okay, I can send you the syllabus of what we are going to learn this term.
Okay, no problem. Then you will send it on WhatsApp. Ne?
Yes.
All right.